All right, with problem number 19, we begin to look at statistics and probability or discrete math issues. The measures of the hand spans of ninth grade students at Tyler High School are approximately normally distributed. So in statistics, when we're told that a set of measures is approximately normally distributed, it really means that the values of those measures will be distributed like a bell curve, like the what we call the normal curve there. And when that happens, you have this what's called a rule of thumb. This is called the empirical rule, EMPIRICAL. The empirical rule tells us that when data are normally distributed, then 68%, roughly 68% of the data will fall between 1 and 2 standard deviations above and below the mean. So about 68% of the data, if the mean were at 7 in this case, and if the standard deviation is 1 inch, then from one standard deviation below the mean to the mean would approximately cover 34% of the data. And from this mean to one standard deviation above the mean, it would include another 34%. So in this case, between 6 and 8 inches would be roughly 68% of the data. Now greater than 7 inches, obviously that's half of the data there, so that would be 50%. So the 68% is better than that. Now less than 6 inches, well, if 50% if 50% of the data is to the right of the mean there, then the amount that's less than 6 inches is going to be less than 84% or something like that. So roughly you have 50% that's greater than 7 and about 34% that's between 6 and 7. So in that case you would have 84% is above 6, so less than 6 would be about 16%. Then the amounts between 5 and 7 inches would be less than half, obviously, so it's about 47 or 48% because it doesn't include the tail part of it there. So in this case, the largest number of ninth graders would be included in the section from 6 to 8 inches. Okay, so now there is a what is called an empirical rule here, which tells you that 68% of the data will fall within one standard deviation of the mean. One below to one above would be 68% of the data. From 2 below to 2 above would be 95%. And finally from 3 below to 3 above, so within 3 standard deviations of the mean, either to the left or to the right, would be 99.7. So this is called the 68, 95, 99.7 rule. Within one standard deviation of the mean lies roughly 68%. Half of that, 34%, would be below one standard deviation below the mean. Half of it, 34%, would lie within one standard deviation above the mean. Then 95% would tell you that half of that is roughly 47.5, whatever. Roughly 47.5% fall 2 standard deviations within 2 standard deviations below, and half of it, 47.5% roughly, falls within 2 standard deviations above the mean. So what you need to remember here is the 68, 95, 99.7 rule, from which you can then calculate roughly those distributions that you see there. It doesn't have to be perfect. It would be 34% and then roughly 13.5% below. As long as you're in the ballpark, and below that would be, I think it's probably 2.5% beyond that. All right, so that's what you need to know about the normal distribution. You have a mean, which is 7, and you have a standard deviation, which is 1. Those are the two things which comprise any normal distribution, the mean and the standard deviation, and you have the 68, 95, 99.7 rule that you will use with that.